Before we start 1.4, does anybody want me to like help you out or go over anything from 1.3? 21 and 22. From a table?
Because I don't know what they want to do with the three.
Well, you basically just start on the inside, work your way out, but.
Do you first do the inside one?
Yep.
And then is that the once you solve the limit of the constant f of x, does it become input of h of x?
So the limit of f of x at c is 6. And then you would do h of 6. G of 3.
I guess we did this.
I'm not working with you for a bit, but I think I got you. Did I not show it to you?
They're not technically due till next month.
Oh yeah, because we're the like now rolls on.
Yeah. No, that's fine. So I'll probably have time to put it in today if you want. Yep. Okay. 1.4 is probably what you remember the most from last year for limits. It's trying to do limits from equations. Who's one we voted to start every day with? Did we do?
Yeah.
Why are we putting the 4 different people? Oh, Milo. You were too close. Let's start with, how should we call on people today? Are we going to just call out random numbers? Are we going to roll dice? Or are we going to roll a bingo roller? That's your decision. Dice, all right? Anybody in particular want to roll dice? Okay, then let's roll to see who's going to roll. 2, 8. So 2 is going to be the second row, 8 is the last person. So read the normal dice first, and then the 8-sided dice is the second.
25.
2, 5. 2, 5. Our juniors. Is that right? 2, 5. Oh, when we're doing dice, one dice tells me which row, column, whatever. Second dice tells me which desk over. So 2, 5 is second row, 5th desk. The numbers are for calling out numbers or bingo roller. So for limits, if I give you an equation and I ask you to find the limit at 5, what's your first option? What is the first thing you're always going to try when you do limits of equations?
Plug in 5.
Just put in the number and see if it works. So essentially, if you have a function value, that traditionally will work only because of continuous functions. Now, it probably says in here somewhere, our goal when we're finding limits is to try to only work with continuous functions if we can. Because continuous functions are the easiest to find answers from. So a continuous function, if we pretend we are super zoomed in on a location. So let's pretend this is a filled in circle and this is extraordinarily zoomed in. A continuous function means the limit from the left, the limit from the right, and the function value in the middle are all identical. And so if we're working with a continuous function and we're asked to find the limit at a random number, well, that random number function value is identical to the limit from both sides. So if you have a continuous function, all of these answers are the same. And so the easiest route is to just put the number into the function, find the answer. Where this method goes badly is when you start having equations where it's not continuous, and then you might be asked to find a function at that continuous spot, or at that discontinuous spot. Now, there are different ways to work around this. So, one way is you can factor. Because if a factor cancels out, then that would be a whole. And we've kind of already talked about wholes from pictures, where the limit value is going to be the same as the whole that isn't there. And so if you factor something, cancel those factors, and reduce it, the reduced answer will let you find that missing number. So that's why we reduce and cancel when we can. A lot of equations just flat out don't factor though. So factoring isn't our only method. Sometimes you will be given a complex equation, which usually means you have fractions within fractions. Those usually look horrible, and they're semi-obvious to us because of the way they look. And so our original plan is just going to be to try to reduce it down to see if we can make it into a continuous function. This is kind of our goal for most of these, is we're going to take discontinuous locations and manipulate them to make them look like a continuous function to be able to just find answers. Our goal is going to be able to take an equation that we cannot plug a number into and change it around so that we can. So this section, when I look at the notes, kind of felt like all over the place, because it starts by just saying, these are the methods we try to find limits. Plugging in was number one. Now, ideally, that would be great. I'll just tell you, plugging in is, this is probably the only section you'll ever be able to just plug a number in. It doesn't mean you shouldn't try, but most of the time that won't work. There are going to be a lot of different things we can try. Basic limit theorems, to me, that's just basically like changing the equation around. So that's like simplifying, that's like using the properties we learned, changing it around so that you can plug a number in and get an answer. Factoring, which I talked about. These two, you probably have zero idea what it's talking about yet. That's okay. I will just show you. It's easier than trying to explain the name. This name is great. It actually makes sense, but it's easier just to show you. We are not doing trig ones yet. Those are in a later section. I think it's like 5 or 6. L'Hopital's, well, it works super easy, but you can't learn L'Hopital's until we do derivatives, which is after limits. So we are only doing essentially half of the methods for right now. And that's okay, because it's going to feel like a lot. Okay, so I believe, if I remember correct, these all are just plug a number in and get an answer. Let's roll it.
2, 7. Come on. It's theta.
I was hoping you could help me with A.
Yeah, for sure. Do you want me to come
Oh, sure.
on?
You volunteered
Okay.
yourself. I wasn't going to, but go for it. I like it. Okay, so we have the limit as x approaches 2 of 3x squared minus 5x plus 4. And our first option, theta, is
Direct substitution.
put a number in. If it works, that's your answer. If it doesn't work, then we have to try something else. Actually, I probably shouldn't have started with A. That's like a normal one. Okay, you got the easy one.
Yep.
Yep. Okay, so 26, 4, 30. Perfect. That's it. Okay, Lisa, who do we got next?
6-3.
Oh, that's my choice. So there's no row 6. So that means I want to try to call on somebody who has not been called on yet. Devin, have you been called on yet?
Yeah, I've got no.
You definitely had that one ready to go, huh? Alex?
For B?
No, we're gonna go to a harder one. So, let's go to C. Natural logs. Oh, all right, well, let's go up there and put some numbers in those. Oh, didn't even check it.
Oh, that's my bad.
3 times 4 would be, yeah. Oh, you multiplied by the 3 before you squared.
Sorry, guys.
Okay, so we've got 12 minus 10 plus 4, 6. Good job.
Just doing my best down
There are going to be plenty of times where I don't check the actual computation, so you guys absolutely keep on the ball on that. Alex, you are stalling a lot. Come on up. Now, what I'm guessing that you are worried about is you don't remember what ln of e is.
Yep.
Okay, but that's okay. You just plug it in to start with. Okay, good. I'm going to guess that you are not alone in this. Okay, ln is log base e. So they don't write log base e for some reason. They will write it as ln for the natural log because it uses a number from nature, e. E and pi are the most common numbers from nature. You know, whatever, they named it, that's fine. So log base e of e means e to what power would be e to the first? 1. So ln of e will always be 1. And then the final answer is 1 over 3e, because there is no simplifying past that. Okay, good. Do you guys probably remember cube roots fine, or do I need to do a cube root? Do cube root? Okay, I'll do it quick. So putting in 4 gives us cube root of 8. You're trying to find what number times itself 3 times is 8. So 2 times 2 times 2. If you get a cube root, it traditionally will only be one of 1, 2, or 3, maybe 4, but I don't remember seeing it before. It's going to be numbers that are small enough to do in your head, unless it's a calculator question, and then in that case, it's not even usually a normal number. So, okay, so I wanted to get to the bottom 2. Actually, I feel decent about the trig ones now, because you guys did pretty well. But should I go over what we do with the 2 theta? All right. So if we plug in pi 6, this is going to say sine of 2 times pi 6. So this will be sine of pi thirds. And that is square root of 3 over 2. Okay, oh, sorry. Square root of 2 over 2 is for the 45 degree angles?
Is that a 3 or is that a?
That's a 3, I wrote it badly. Square root of 3 over 2, isn't that right?
That's right.
Yeah.
That's right, I just thought it was written as.
Oh, yeah, when I have to write at the bottom of the whiteboard, it doesn't go well. I was hoping somebody could do another logarithm one, because those usually go the worst, because you guys didn't really you did them in pre-calc, but you mainly did them on, like radioactive dating and stuff like that. I don't even know if AP pre-calc did that. Did you guys do radioactive dating, or
I think we brought up. I don't remember.
did you do logarithms much at all?
like,
Oh, what are we doing?
Yes, we can do that.
Okay, well,
I can.
no. We would definitely want to pick somebody who doesn't know how to do it. It's great if you know how to do it. I like calling on people because it forces them to learn it even if they don't want to.
4-3.
Nobody.
6-3.
I saw you only roll one dice. No, let me try. It's a short name, it's like 4 letters. Nah, I'm giving up. Ryan, I wasn't gonna think of Ryan. Okay, so plugging in is obviously normal, but I was just wanting us to come up with the answer of logarithms to remember how to do them. And feel free to call on people to help you if you want it. Yeah, so we have log base 3 of 9.
write it or add the answer?
If you know the answer, just write it, that's fine. Correct. Logarithm answers are powers. Nice job. So the base is what determines what you're going to try to find the power of. So in your head, that means 3 to what power is 9? Logarithms are just a weird calculation, but they design them so they can be done on an actual calculator. If it makes you feel any better, I'm old enough that graphing calculators weren't really common because they were stupidly expensive. And so they had logarithm tables in the back of every textbook. And you just had to look that up in a table and find the answers. Kind of horrible. It was like using a dictionary for everything. Okay, nope, skip. No, that's from a graph. I know we had the one-sided limits. I kind of feel like I want to do the one-sided limits tomorrow, though. So I thought we would probably be better off practicing the different techniques you haven't learned yet first. And the reason the method for one-sided limits, it's allowed on the AP test, nor do I like it. It basically just has you pick a number close to it and plug it in. And I don't like it. So I'm going to teach you a different method that I find a lot easier that doesn't need a calculator. But I'll show you both ways. So that's kind of why I save it for tomorrow. Okay, I wanted to get to this one. The rationalization technique. Now here's the weird part, is you guys for the last 4 years have been trained repeatedly over and over that if you ever have the square root on the bottom of a fraction to not have that. So you were told to rationalize it, so you wrote it like, usually it was for trig. Usually, so you had to write it as square root of 2 over 2. But the weird thing is, there's nothing wrong with writing 1 over square root of 2. The reason that you have to rationalize is pre-calculators. It's when you had to look up how to do long division, and you can't have a decimal on the outside of long division. So that was the only reason for rationalization. 2, rationalization does not mean multiply the bottom by a square root to make the bottom a normal number. Rationalization actually just means that you are going to multiply by another square root to change its form so that it is not a square root. Rationalization can be done on the top or the bottom of a fraction. So, you guys were taught what you did was correct, but most people come in here with the impression that it has to be that way, like, because that's what you've done for so long. So for this problem,
2-7.
not allowed? Oh, I was gonna say the dice don't lie. We can have repeats, but okay. She can just lie and say it was a different number.
6-6.
Me again. This is why I make people call on Emmanuel. Okay, what's the issue with plugging -1 into this problem? I don't remember what page it's on, I don't have page numbers. Okay, you would divide by 0, or I believe if I remember right, the top actually turns to 0 as well, doesn't it? Yeah.
Yeah.
So you would get 0 over 0, which is an indeterminate. That's even worse than just divided by 0. There actually is levels of badness. 0 over 0 is the worst thing possible for us. So we're going to do something called rationalization, which is going to be multiplying the numerator and denominator by a similar square root. Does everybody here remember imaginary numbers decently well? No, I can't remember now. He doesn't even know we're talking about yet. Like bar. Yeah, okay. I felt that was wrong in my head, but I was actually pretty close. Or both. Do you remember what a conjugate pair is?
No.
Well, that didn't take very long. Maybe you should have been paying attention for measuring numbers too. Does everybody remember what a conjugate pair is? Oh, look at everybody. I said, who remembers measuring numbers? And everybody's like, oh yeah, I remember that. Okay? Conjugate pair of 4 plus 3i is,
4 minus 3i.
yeah. So the conjugate pair part is just meaning that you change the symbol in the middle. Conjugate pairs aren't only for imaginary numbers. We are going to rationalize by multiplying by the conjugate pair of the numerator. So we are going to multiply top and bottom by square root plus 1. Now this method seems and feels like it should do nothing and make the problem worse, but it generally works. Like, you are going to be given specific problems where this method works. So whenever you run into a square root, this is frequently a method to try. Okay, so I've got square root of x plus 2 times square root of x plus 2, and I get x plus 2. And then the reason we picked this specifically is because this is a difference of squares. The middle terms cancel out when you FOIL it. So when the middle terms cancel out, then the last term would be negative 1 times positive 1, which is minus 1. In the denominator, this will go against your natural, like you're going to want to multiply this out of habit. Don't multiply it out. I mean, it feels unnatural to do this. Don't multiply out bottom. Numerator turns into what? X plus 1. X plus 1 can now cancel from top to bottom. And then the numerator is just a 1. Now the denominator looks like garbage, but works fine because now we can get an answer when we plug in negative 1. That's all we actually cared about. Now if I plug in negative 1, I get 1 over 2. And obviously the picture's right there. There's a hole at negative, yeah, a hole at negative 1. So John, if, what I was trying to do is sometimes when I'm standing there, the monitor is really easy to see. Okay. Possibly for you guys. Yeah. Okay. Do we get the idea of how to do it? Not necessarily that it's easy to do it yet. Okay, so I believe the one right below it is similar, right? Yes. I was hoping you guys could try that one on your own. Square root is on the bottom, so in this case, you're gonna rationalize the bottom. Doesn't matter if it's top or bottom. But try the method of multiplying by the conjugate pair of the square root. Did I miss the, oh, they're down there, okay. If anybody gets done with it relatively quickly and feels confident in theirs, if they wanna go up and write it down, that'd be great, rather than just calling on somebody. But otherwise, we can call on somebody. Why do so many people have their Chromebooks open? Quit trying to multitask, people. If you are reading the notes along with me, that's fine. Some people do that. Do you guys need help starting it? Okay. What are we gonna multiply top and bottom by? 3 plus the root. You change the sign in the middle and that's it. I think I heard somebody say -3 minus the root. That should still work as well. Where do we get chicken? Oh, we played a game.
No.
We open that up, we're gonna be playing a game.
There you
The face says otherwise. Should we be done with it already? We got it. It's not gonna be x plus 4. That's why. So the negative sign has to distribute out to x plus 4.
That's what I.
You multiplied it out, right? Yeah. I wonder if a lot of people are getting stuck on that same spot. Your denominator should not say 3 minus x plus 4. Actually, 3 is actually very wrong, it should be 9. It should say this. The clue to tell you if you're doing it correct is that it should be sort of like x minus 5. My guess is this is going to be negative x plus 5. So we've got 9 minus x minus 4. Anybody remember from the last couple of years what happens if you cancel two factors that are reversed? It's a -1. Yep. So if you write this as 5 minus x, that's fine too. Doesn't really matter how you write it. But x minus 5 and 5 minus x can cancel, and then they leave a -1. And it doesn't matter if you leave the negative one on top or bottom. It works either way. And then there essentially is no bottom because it's a one. But the reason this works, even though it looks terrible, is the fact that we can plug 5 in and get an answer. So we would have negative 1 times 6, and so that'd be negative 6. I'm going to guess, it seems like this is gonna be one you guys will want to practice on. So maybe if there's not enough of these in the homework to practice, I'll try to find some extra ones. This pretty much just relies on a lot of algebra skills. And so this is where we start running into problems where if somebody in pre-calc, I believe Sarge referred to them as the odd all-stars, would just like write the answers down from the back of the book or copy the answers from somebody else. This is usually where somebody who kind of faked their way through pre-calc starts getting stuck because there's a lot of algebra in these problems that you have to know how to do that are not even like the main part of the problem. They're supposed to be something that's just automatic for you to do now. And I get that you guys have had all summer, so there's definitely some remembering to do, in the first month of school. But this is a lot of algebra. You learned a new method to try to find answers, but it's all algebra work. I accidentally went past the simplification of complex fractions there at the bottom of this page. And I am not going to do the same method that the lady that writes the notes does. So I usually will attach the filled out notes to the homework. And so some people open up the filled out notes while we're doing them together, and that's fine. Just know that I do it a totally different method. And so if you don't like the way that I'm doing it, you can also switch and try the method she teaches. One of them might make more sense to you, right? A lot of these problems are gonna have multiple ways to do them. Okay, if I put 0 in, I get 0 over 1/4 minus 1/4, so I get 0 over 0. Right away, plugging 0 in doesn't work. So what we are gonna do is take that and simplify it down into a single fraction. So I would start by writing the numerator as a fraction. So we have a numerator and a denominator. The denominator, I would like to make a single fraction, because currently it's 2 fractions. So the way we make single fractions is common denominators. So I don't have a ton of room, but I'm going to multiply the first fraction by x minus 4 over x minus 4. Second fraction by 4 over 4. The denominators have nothing in common, so you just multiply them by each other. And then this will turn into x minus 4 over 4 times x minus 4 plus 4 times 4x minus 4. So it's just normal common denominator with algebra. And then in my next step, I'm going to put these two together. X minus 4 plus 4 is x. If things start canceling, that usually is a good sign for us. This chair here is actually quite nice. We should call somebody. We need to involve more people.
3 in.
Amelia. Do you remember what to do when you have a fraction over a fraction? There's different ways to say it.
Cancel it.
You might need it correct.
Like multiply it. Like
What would you write? How's that? Or would it be easier for you to just come up and write it?
No.
Oh.
Like, he like times like the bottom of it like to the top.
Okay, do you remember what you do with it when you do that? But you are correct. So, some of your prior teachers might have called it KFC, even though KFC doesn't fit. It's keep, change, flip. The middle school teachers call it KFC, even though it doesn't, it's KCF. So it's keep, change, flip, you keep the top. Flip the bottom upside down and change to multiplication. Oh my God, it's bad for. The x's would cancel. We now no longer even have a fraction once we reduce the base. Okay, now, in the original problem, the original equation that we were given, 0 and 4 are both numbers that we are not allowed to use. Because 0 gives you an indeterminate, 4 gives you an undefined fraction. And so 0 and 4 are numbers that are not allowed to be used. But that's only if you're doing a function value, like they would be wholes, or vertical asymptotes. We're doing a limit, which isn't finding on the number, it's finding around it. So we're allowed to just change an equation around to a different form to see if we can do the problem. So even though 0 and 4 technically aren't allowed to be used, we can use them for the limit because it's different than a function value. You guys want to try the second one on your own? It's pretty much the same, but obviously different numbers, different locations. Or absolutely ask away if I wrote something you didn't understand too. Like that's going to be pretty important. Maybe I should bring the dice roller out of retirement. So Mr. Ware made us a dice roller, but I don't know if the metal ones are too big for this one. So we also bought a Castle on Amazon. You keep getting repeated numbers, so this is kind of a way around that. I have no idea which one's yeah, we'll see if they roll down or not. Oh, okay, I thought it was even too big.
Castle it is.
Yes.
Okay. She's pretty excited.
What do we got?
4-3.
Oh, where did you roll 4-3?
Yeah.
This isn't super random here.
5-3.
5-3. It is. Winston, you got rolled. How confident are you feeling about doing this one? Do you want to take a minute or two to try to work with people around you first? Otherwise, if you're already done, you could just come up and write it. You don't have to explain it. I was just hoping you could write what you got once you got to that point. You can check with people around you. Go for it. This isn't to try to make you feel anxious about your answer.
Oh, wait.
just putting it up there.
This is what you do when that's it.
Oh, you were just grabbing it. I didn't even think to ask, do you guys need practice at factoring? I was just kind of going on the assumption that you did a lot of factoring the last 2-3 years. If you feel like you need individual help with factoring, feel free to just come, I can kind of brush you up on that if you need it. But I skipped the factoring questions because I was kind of under the assumption you kind of remembered how to factor for the most part. But I absolutely can go over some of those with you. Winston, are we 50-50 now? Would you like me to pick somebody else? Okay. At least we need to roll again. Are you volunteering? Oh, that'll teach you for trying to brush your hair, huh? You guys can pair it up if you would like. Pair it up. It always feels safer in pairs. Oh, you're a volunteer. By chance, did we roll a 3-2 or a 3-3?
I have 5-8.
That's very close.
We have one question quick before we do it.
Do you distribute the negative sign to the x?
That is a great question.
Or do you
Because that's
just
what I did.
take this and subtract it and just have X?
That is a great question.
Okay.
That's what we're trying to figure
Thank
out.
you.
Oh,
Yeah, yeah.
oh, okay.
Which one we gonna do?
So now you guys are you're just gonna like rock, paper, scissors, who's is right?
I guess.
Uh-oh. Well, we're really chancing this one. Otherwise, don't forget, you can ask the class.
Well, I don't.
Okay, wait. John, do you distribute it or do you just subtract?
So they're not sure about the negative sign on the top.
Distribute that like 2, right? Or do you just take that?
Phoebe, you distribute it.
Okay.
Yep.
The thing is,
Okay.
I think you just,
Yeah, I
I
go.
think you just,
Okay. Well, thank you. I just don't really know.
No, that's why we practice some of these, because little things take forever.
Take a lot and multiply with the entire expression, it's just not.
So it feels kind of ridiculous to say, what you are gonna find this year is you will probably find the new calc ideas not terrible. Where you're gonna have the hardest time is all the algebra work. So we're gonna be learning the calc ideas and then like doing them on problems. But where most people get tripped up on tests, on whatever, is the actual algebra. So on this numerator, you have to distribute out that minus sign from the fractions. Because if you are subtracting a fraction, you are subtracting the entire top. And so if the top had more than one term, the minus sign goes to more than one term. I actually have no idea what the answer is. I didn't finish it. That would have been smart for me to do. So you did 2 over 2 plus x minus 2 plus x, 2 x. 2 minus 2 would be 0. You'd have minus x on the top. 2 plus x, and then the x's cancel. Ooh, you are awfully close. Oh, is it bothering you too much? You had to go fix it? I won't lie, I've never seen that before. Okay, you did the problem correct. If the numerator appears to all cancel out, you have to leave a 1 in the numerator. If a denominator cancels out, and is just a 1, you don't need to write it. Like, if you have 5 over 1, you would just write 5. But if a numerator, and the only thing left is a 1, you still have to keep that. So it should be negative 1/4. Okay, I wanted to stop here because we only have like 5 minutes left. If there's people in here who have 1.3 done and wanted to show it to me instead of turning it in later, they certainly can. I wasn't expecting you to have it done, but if you do, no problem.